Now, let's review the various building block objects found under the Resources menu. The first item is runtimes, which are the templates for cluster resources used for processing data pipelines and attached to notebooks to provide more compute resources for running experiments. The types of runtimes that can be defined depend on the infrastructure that the application is installed. Here we see some of the runtime types for AWS, while here are examples on GCP. The application has several default runtimes, but new ones can be created easily by clicking the plus button on the top right of the screen. Here's an example of creating a new runtime with the runtime type set to GCP Dataproc cluster. The available configuration fields will vary based on the value selected for runtime type. Also, as mentioned, the available runtime types will vary based on the cloud infrastructure that the application is installed. More details on runtimes can be found in the documentation on the Syntasa Help Center. Next, we have connections, which is where users define the external locations, databases, and APIs from where the raw data should be read and the resulting process data should be written. Here are just a few examples of connections that can be defined. Similar to runtimes and other objects, new connections can be created easily by clicking the plus button on the top right of the screen. The connection type dropdown displays all available connection types. Also, it's common to create several instances of a single connection type. For example, if incoming and outgoing data are maintained in different S3 buckets, then separate S3 connections can be created. Once created, here's an example of an S3 connection. The configuration fields vary per connection type and will adjust when the connection type is selected. The connections defined here will be available and reusable in apps as we build our solutions. Our next Resources menu item is data stores, which are the Syntasa application's internal locations where the apps and the data they produce are saved within the infrastructure's cloud. There are three types of data stores: Event Store, ID Store, and Intelligence Hub, but Event Store is the type used for saving the apps and their data, and thus is the most commonly used. For most event stores, the user simply needs to provide a name. The remaining details of the path and database name are filled in automatically per default values configured by the system administrator. As we'll see in the overview of apps, there are three paths and databases for the event store. The development and production paths store the respective version of an app. The snapshot path captures a history of changes in the app. The other data store types, ID Store and Intelligence Hub, are used in certain solutions and are described in more detail in the Syntasa Help Center. Our next Resources menu item is Files. This option provides users with a quick way to upload files to the application's cloud storage without needing direct access to the cloud. While a productionized pipeline will be reading data from a regularly updated feed, uploading sample files directly from the interface is useful when testing an app and when users' access to the cloud storage is restricted. Various file types are supported, such as JSON, delimited, and jar files. Also, multiple files can be uploaded to each object. The files can simply be dragged into the file object to initiate the upload. Once uploaded, the file objects and files can be accessed within apps and notebooks. Finally, under the Resources menu, we have Events. This feature provides the capability to define events that can be used to trigger jobs instead of them being started at a regularly scheduled time. The types of events available for configuration are File Watcher and Adobe Feed Watcher. To configure a File Watcher event, the object needs a connection, which we set up previously, a path within that connection's location, and a file name pattern to monitor. At the appearance of a new file matching the criteria, the application will raise an instance of the event. The Adobe Feed Watcher is specific to Adobe Feeds and can be configured in detail whether files are arriving daily or hourly, and if hourly, the event can be configured to be raised every hour or only after the complete day of files has been received. Depending on your solution and the needed timeliness for the data, defining an event to kick off certain jobs can be beneficial and optimal rather than scheduling them at a specific day and time.